Hello student, welcome all of you of B.Sc.TY student, semester 5th and paper is linear algebra. So this is lecture 1 lemma. In lecture 12th, notice that show that V by W is a vector space. V by W is a vector space. V by W is quotient space, which we have already discussed in the lecture 12th. So in lecture 12, this is a lemma. If V is a vector space over field here, and if W is a subspace of the V, then V by W is a vector space over here, where for this one element nu 1 plus W, this is second element, nu 2 plus W belong to V by W and alpha belong to field here, satisfying these two composition or defining this composition on it, it form the vector space. It form vector space. So these two operations are very important because with these two operations, V by W form a vector space. So see here, be carefully, because we are applying these two things on our vector space V by W, because these are the two main binary operations. Okay. So now today, in lecture 13th. So in lecture 12th, we have already proved that the given two operations, that means addition and scalar multiplication. So both are well defined. Both are well defined. That means it is true for any elements of V by W. Now our target is that we have to show that V by W is a vector space. So if a V by W is a vector space, see here, if V by W is a vector space, so it must be necessary that V by W with respect to plus is an abelian. This is our first target, is an abelian. So now, to show that it is an abelian, we have to show that some laws, and that is a commutativity of addition. Commutativity of addition. So in commutativity of addition, if we choose any two element, nu 1 plus W, nu 2 plus W, both belong to V by W. So in commutative law, we have to show that like this, A plus B is equal to B plus A. That means add first A in B, or in B add A, or B in A or A in B. That means it is same thing. So this is commutativity law. Now we have to show that it is for these two elements. So we add this nu 1 plus W, nu 2 plus W. So with respect to our composition, that is first composition, addition of two elements of V by W. How can we do the addition of them? So nu 1 plus W, nu 2 plus W can be written as nu 1, nu 2 plus W, because it is given in lecture 13. We have already discussed how to do nu 1 plus nu 2 W. So nu 1 plus nu 2 and then W. It is given. It is defined term. Whenever we have to add two vectors, add two elements of the V by W, then take addition like this. It is defined. Don't do on your own risk. It is defined. Nothing to do. It is already given. And we apply here nu 1 plus W plus nu 2 plus W is nu 1, nu 2 plus W. Now we know that nu 1 plus nu 2 and nu 2 plus nu 1 both are commutative. This is a commutative because V is an abelian. V is a vector space. Therefore, this sum we can write in this way. And again, nu1 plus nu2 plus w can be written as nu2 plus nu1 w is nu2 w, nu1 w. So therefore, nu1 w plus nu2 w is equal to nu2 w plus nu1 w. So hence, it satisfies commutative law. Now next is the associative law. Next is associative law. In associative law, we choose three elements. One, nu1 plus w. Second, nu2 plus w. Third, nu3 plus w. And all these elements belong to V by w, because we are trying to show that V by w is a vector space. Okay, no problem. We are trying to associative law. So first we are taking sum of these two elements. So if we apply the addition of these two elements, then we can write nu1 plus nu2, that means element of the V, and then plus w. Again, now this consider as a first element and this total as a second element. Then again we can do nu1 plus nu2 plus nu3 plus w. So now nu1, nu2, nu3, all these three elements belong to capital V. Nu1, nu2, nu3, all these elements belong to capital Nu. So if all these nu belong to capital V, so capital V is an abelian group. So it is abelian group. So elements of V satisfy associative law. So therefore I write associate nu1, nu2 first, and after that nu3, because nu1, nu2, nu3 are the elements of vector space V, and therefore we can associate them. Again I write this in this way: w, this plus w and this plus w by our binary compositions given in the definition of quotient space. And again we can nu1 plus nu2 plus w, again we can split it like this: nu1 plus w, nu2 plus w, and nu3 plus w. So these are two properties, commutative of addition and commutative of associative. Now next is the existence of identity. So existence of the identity is very trivial, because this is a zero vector, this is a zero vector in the V. So if w plus 0, so we can again w, and w first class including the V by w, because every subspace is itself a coset. We already proved this. Now this is a zero element plus any element of the V by w. So then we can do this sum, w 0 plus nu, and this is the w plus nu. That means in w plus 0, if we add w plus nu, we get again w plus nu. So what is the identity element? So this is the identity element over addition. Next is existence of additive inverse. So for V by nu plus w belongs to V by w, there exists minus nu plus w, and this element is the inverse. If we do sum or applying the addition on them, so we get nu plus w plus minus nu plus w. Sum do like first property, and we get nu minus nu plus w. So this nu minus nu is zero element, because this nu belong to vector space V. So vector space V is abelian with respect to addition, and therefore nu minus nu must be 0. So 0 plus w, and 0 plus w is nothing but identity element of V by w. Remember these. So we know that you recall yourself what is definition of vector spaces. So in vector spaces it must be compulsory that V by W is abelian group. So we have seen that V by W is a commutativity, V by W is associative, V by W has a additive identity, V by W has the additive inverse. So definitely V plus is an abelian group. So up to this, V by W plus is an abelian. And next is scalar multiplication. So scalar multiplication is given already in the definition, so no need to show that. Now we discuss about the all four properties. So take any alpha beta belonging to field. Now nu1 plus w, nu2 plus w elements of V by W. Then now first property is multiplication is distributive or addition. So these are element of V by W, and take this alpha. So second point is given that in definition of quotient space. So what is the alpha into this? So how can do the sum of these? Nu plus nu2 w multiplying by alpha. So alpha into this plus w, this. Now capital V is a vector space and nu1 nu2 be the elements of vector space. So we can write this alpha nu1 alpha nu2 plus w. Again by the definition of a quotient space, and second point is given for to show that the V by W is a vector space. So again we can split in this way. Again we can take alpha common, no doubt, and we get this is equal to this. You pause video, dear student. You pause video, think some things for a few minutes and try to understand this. And from this, I suggest you that try to solve property second, try to prove property second, property third, and property fourth. So I left this as an exercise, and therefore V by W is a vector space of the F over the field F of these two compositions. If we show that V by W is a vector space, then those two compositions are very, very important, which we have already discussed. So dear student, it is very important to write second property, third property, fourth property in your book. Try to prove it. If you prove it, then I will understand your studies going on. So I left this an exercise 0.234. So student, today we stop it here. In next lecture we will discuss on some various important points. Thank you very much.